Welcome to our deep dive into backup and recovery techniques in data center technologies. In today's digital world, data centers are the backbone of business operations, storing and managing vast amounts of critical information. But what happens when disaster strikes? Whether it's hardware failure, cyber attacks, or natural disasters, having robust backup and recovery strategies is essential. In this video, we'll explore the key methods and best practices that keep data safe and ensure business continuity. Let's start by understanding why backup and recovery are so crucial in the data center environment. Data is the lifeblood of modern organizations. Losing access to critical data can halt operations, damage reputations, and lead to significant financial losses. That's why data protection is a top priority for data centers. Effective backup and recovery plans not only safeguard information, but also help organizations meet regulatory requirements and maintain customer trust. In this scene, we'll discuss the risks of data loss and the value of proactive protection strategy. Data loss can occur for many reasons, from accidental deletion and hardware malfunctions to malicious attacks and natural disasters. Understanding the different types of data loss events helps data centers prepare appropriate responses. For example, ransomware attacks require different recovery strategies compared to power outages or floods. By identifying potential threats, organizations can tailor their backup and recovery plans to address specific vulnerability. Before diving into specific techniques, let's clarify some core backup concepts. Backups are copies of data stored separately from the original, allowing recovery in case of loss. Recovery refers to restoring data from these backups. Key terms include Recovery Point Objective (RPO), which defines how much data loss is acceptable, and Recovery Time Objective (RTO), which sets the maximum allowable downtime. Understanding these concepts is fundamental to designing effective backup strategies. Full backup is the most comprehensive type of backup. It involves copying all data from a system or database to a separate storage location. This method ensures that every file is protected, making recovery straightforward. However, full backups can be time-consuming and require significant storage space. They are typically performed at regular intervals, such as weekly, with other backup types used in between to save time and resources. Incremental backups only copy data that has changed since the last backup, whether it was a full or another incremental backup. This approach saves storage space and reduces backup time. However, restoring data may take longer as it requires the last full backup and all subsequent incremental backups. Incremental backups are ideal for environments with frequent data changes and limited storage resources. Differential backups capture all changes made since the last full backup. Unlike incremental backups, each differential backup grows larger over time as it includes all changes since the last full backup. This method strikes a balance between storage efficiency and recovery speed, as only the last full backup and the latest differential backup are needed for restoration. Snapshots are point-in-time images of data, often used in virtualized environments. They allow quick restoration to a specific state without copying all data. Snapshots are efficient for short-term recovery and testing, but they are not a substitute for traditional backups, as they may not protect against hardware failures or site-wide disasters. Tape backups have been a staple in data centers for decades. They offer reliable, long-term storage at a low cost. Tapes are often stored off-site, providing protection against on-site disasters. However, tape backups can be slower to restore and require careful management to ensure data integrity. Despite newer technologies, tape remains a valuable part of many backup strategies. Disk-based backups use hard drives or solid-state drives to store backup data. This method offers faster backup and recovery times compared to tape. Disk systems can be configured for redundancy and are often used for both short-term and long-term storage. However, they may be more expensive and require regular monitoring to prevent hardware failures. Cloud Backup has revolutionized data protection by offering scalable, off-site storage managed by third-party providers. Data is encrypted and transmitted over the internet to secure data centers. Cloud backups provide flexibility, easy access, and disaster recovery capabilities. However, organizations must consider bandwidth, security, and compliance requirements when choosing cloud solutions. Many organizations adopt hybrid backup strategies, combining on-premises and cloud solutions. This approach leverages the speed of local backups with the resilience of cloud storage. Hybrid strategies offer flexibility, allowing businesses to optimize costs, performance, and protection based on their unique needs. We'll explore how to design an effective hybrid backup plan in this scene. Scheduling backups is critical to ensure data is consistently protected without disrupting operations. Organizations should define backup windows based on business hours, data change rates, and system performance. Regularly scheduled full, incremental, or differential backups help maintain up-to-date copies and minimize data loss in case of an incident. Retention policies determine how long backup data is kept before being deleted or overwritten. These policies are shaped by regulatory requirements, business needs, and storage costs. Proper retention ensures that organizations can recover data from the appropriate point in time while managing storage resources efficiently. Securing backup data is just as important as protecting live data. Encryption ensures that even if backup media is lost or stolen, the data remains unreadable to unauthorized users. Organizations should implement strong encryption protocols for both data at rest and in transit, especially when using cloud or offsite storage. Automation streamlines the backup process, reducing the risk of human error and ensuring consistency. Automated systems can schedule, monitor, and verify backups without manual intervention. This allows IT teams to focus on other critical tasks while maintaining reliable data protection. Regularly testing backup and recovery processes is essential to ensure data can be restored when needed. Testing helps identify issues, validate procedures, and build confidence in the backup system. Organizations should schedule routine recovery drills and document the results to improve their disaster recovery plans. Disaster recovery planning goes beyond backups. It involves creating a comprehensive strategy to restore IT operations after a major incident. This includes identifying critical systems, defining recovery priorities, and establishing communication protocols. A well-designed disaster recovery plan ensures that organizations can resume operations quickly and minimize losses. Storing backups offsite protects data from local disasters such as fires, floods, or theft. Remote backups can be achieved through physical transportation of media or by transmitting data to remote servers or cloud storage. Offsite strategies add an extra layer of resilience to any backup plan. Replication involves creating real-time or near real-time copies of data across multiple locations. This technique ensures high availability and rapid recovery, as data is always accessible from another site. Replication is often used for mission-critical systems that require minimal downtime. Deduplication is a process that eliminates duplicate copies of data, reducing storage requirements and improving backup efficiency. By storing only unique data blocks, organizations can save space and speed up backup and recovery operations. Deduplication is especially valuable in environments with large volumes of similar data. Compression reduces the size of backup files, saving storage space and speeding up data transfers. Modern backup solutions often include built-in compression algorithms that balance space savings with processing power. Proper compression can significantly lower costs and improve backup performance. Virtualization has transformed data center backup and recovery. Virtual machines can be backed up and restored quickly, and snapshots allow for rapid rollback to previous states. Backup solutions designed for virtual environments offer granular recovery options and support for dynamic workloads. Application-aware backups ensure that critical applications such as databases and email systems are backed up in a consistent state. These solutions coordinate with applications to capture data without corruption, enabling reliable recovery and minimizing downtime for essential services. Backing up physical servers differs from virtual servers. Physical backups often involve imaging entire disks, while virtual backups can leverage snapshots and replication. Understanding the unique requirements of each environment helps organizations choose the right tools and strategies for comprehensive protection. Data centers can choose from a variety of storage media for backups, including tapes, disks, SSDs, and cloud storage. Each option has its advantages and trade-offs in terms of speed, cost, durability, and scalability. Selecting the right media is crucial for meeting backup and recovery objectives. Backing up large volumes of data can strain network resources. Organizations must plan for sufficient bandwidth and minimize network congestion during backup windows. Techniques like throttling, scheduling, and data compression help optimize network usage and ensure reliable backups. Continuous monitoring and reporting are vital for backup success. Automated alerts notify IT teams of failures or issues, while detailed reports provide insights into backup status and trends. Proactive monitoring ensures that problems are addressed before they impact recovery. Documenting backup policies and procedures is essential for consistency and compliance. Clear documentation helps staff understand their roles, ensures repeatable processes, and supports audits. Well-documented policies also make it easier to train new team members and adapt to changing requirements. Limiting access to backup systems is a key security measure. Role-based access control (RBAC) ensures that only authorized personnel can manage or restore backups. This reduces the risk of accidental or malicious data loss and helps organizations meet security and compliance standards. Immutable backups cannot be altered or deleted for a defined period. This feature protects against ransomware and insider threats, ensuring that backup data remains intact and available for recovery. Implementing immutability is an effective way to enhance backup security. Many industries have strict regulations regarding data retention and protection. Backup strategies must align with legal requirements such as GDPR, HIPAA, or SOX. Compliance-focused backups ensure that organizations avoid penalties and maintain customer trust. Business continuity depends on the ability to restore operations quickly after an incident. Backups play a central role in continuity planning, ensuring that critical data and systems can be recovered with minimal downtime. We'll discuss how to integrate backup strategies into broader business continuity plans. Many organizations rely on software-as-a-service (SaaS) platforms for email, collaboration, and more. While providers offer some data protection, it's often the customer's responsibility to back up their own data. Specialized backup solutions for SaaS applications ensure that cloud-based information is protected and recoverable. Endpoint devices like laptops and smartphones often contain valuable business data. Backing up endpoints ensures that information is not lost due to device failure, loss, or theft. Endpoint backup solutions can be managed centrally, providing consistent protection across the organization. Databases are critical to many business operations. Specialized backup solutions ensure that databases are backed up in a consistent, usable state. These solutions often support point-in-time recovery, allowing organizations to restore data to a specific moment before an error or incident occurred. File servers store shared documents and resources for teams. Regular backups of file servers prevent data loss from accidental deletion, corruption, or hardware failure. Solutions should support versioning and quick restoration to minimize disruption to users. Virtual machines, VMs, require specialized backup solutions that can capture the entire VM state, including configuration and data. VM backups enable rapid recovery and migration, supporting dynamic data center environments. Features like incremental backups and deduplication enhance efficiency. Network devices such as routers and switches store configuration data that is vital for connectivity. Backing up device configurations ensures that networks can be quickly restored after hardware failure or misconfiguration. Automated solutions simplify the process and reduce downtime. Storage arrays consolidate large volumes of data for multiple applications. Backing up these arrays requires solutions that can handle high data throughput and complex architectures. Advanced features like snapshots, replication, and deduplication are often used to protect storage arrays effectively. Many data centers still rely on legacy systems that require specialized backup approaches. Compatibility and support can be challenging, but maintaining backups for these systems is essential for regulatory compliance and business continuity. Tailored solutions ensure that even outdated systems are protected. The rise of Internet of Things (IoT) devices introduces new backup challenges. These devices generate large volumes of data and may have limited local storage. Centralized backup solutions can aggregate and protect IoT data, ensuring that valuable information is not lost. Edge computing brings data processing closer to the source, but also creates new backup requirements. Edge devices may operate in remote or harsh environments, making reliable backup and recovery essential. Solutions must support decentralized data and ensure that edge data is synchronized with central repositories. Backup and recovery landscape is constantly evolving. Emerging trends include the use of artificial intelligence for predictive analytics, automation for faster recovery, and integration with cybersecurity tools. Staying informed about new technologies helps organizations enhance their backup strategies and stay ahead of threats. Effective backup and recovery are vital for data center resilience. By understanding different techniques, implementing best practices, and staying current with technology trends, organizations can protect their data and ensure rapid recovery from any incident. Remember, a robust backup strategy is the foundation of business continuity and peace of mind in today's digital world.